Hi everyone, welcome back. In this video, I will be deriving the power rule. As you see below, the derivative with respect to x of some x to the n equals n x to the n minus 1 dx. But where does that come from? How did mathematicians determine that? What's the origin of the power rule? So when we derive the power rule, we're going to look for the derivative of some function f of x that equals x to the n. So we're going to call this y, and we'll define this as y naught, or y sub 0. And if we change x by delta x, we will have a new y value, and we'll define this as y sub f. And then the change in y will be the difference between the second, final, and first initial values. Shown here, delta y equals the quantity x plus delta x to the n minus x to the n. To figure out this any further, we need to know, we're going to first factor out x from the first term. And with that, we're left with this. So now, if we know the series expansion for the function 1 plus x to the p is what you can see right here, we can expand it, and if we're assuming small changes in x, we can ignore any of the terms where delta x to the n, where n is greater than 1, since we're letting delta x go to 0. So all those terms are about 0. If we do that, we only really need the first two terms of the expansion, the 1 plus px term. So with that expansion, substituting that expansion in, we're left with, replacing that function, we're left with x to the n times the quantity 1 plus n times delta x divided by x minus x to the n. Multiplying x to the n through, we have x to the n plus n x to the n minus 1 times delta x minus x to the n. We can cancel out the two x to the n's, and we're left with delta y equals n x to the n minus 1 delta x. And since we let those changes go to 0, we can replace the deltas with infinitesimals. So it becomes dy equals nx to the n minus 1 times dx, which is the power rule. I hope you liked that video. Let me know any other ideas. Comment below what else you'd like to see, and I will work on making those videos. Have a great day, everyone.